In the Docker, we have all the containers we need. Valhalla for routing. Keycloak for authorization and authentication. MongoDB as a database. Redis for messaging. The server part is written in C++ and C#. Authorization is required to work with the application. After authorization, the user can see objects and controls corresponding to his rights. Now we see several graphical objects on the map. Area as a polygon in the center. And multiple vehicles traveling on random routes. Object movements are emulated by a special program that uses gRPC or DAPR to change the coordinates of objects. Needless to say, in the same way, third-party systems can send real data of real objects to the system. You can show the control panel on the right. In particular, the properties of the selected object. There is a built-in positioning function for vehicle location area. Advanced scaling, where the detail of the displayed object and its number depend on the selected scale. One of the main functions is to search for tracks in the archive. In this case, we search by object parameter and time interval. We can see the history of object movements with the parameter track_name equals Lisa_alert. Now Lisa_alert too. Let's shorten the time interval. Let's see what we have in the database right now. In the Geometry table, we can find data about the geometry of our lines, polygons, and point objects. The Tracks table is a time series table where data about object movements is recorded. This allows us to always query retrospective data. Here are a few words about the SDK. In essence, the SDK is described in the protofile, and using Google Protocol Buffers technology, integration can be performed in any programming language. Several examples are also written in C# and C++. Objects can have an unlimited number of properties, both system-defined and user-defined. It is possible to change the color and shape of an entity in real time.